Now let us derive an expression, a good expression to find the time period of a pendulum where the length of the pendulum is comparable with the radius of the earth, or the length of the pendulum is infinitely long. So the expression would come out like this: T will be equal to 2 pi 1 over G times 1 over L plus 1 over R, where L is the length of the pendulum, R is the radius of the earth, and G is the acceleration due to gravity. Now, so this is your planet Earth. I have redrawn it here. So this is the center. This is the center of the earth. Let it be O, this point. And from here to this point is the radius of the earth. Let it be A, right? And let me take this point as B, the point from which a pendulum is hanging. This is the mass. This is the bob of the pendulum at a displaced position. From B to this point, the length of this segment from B to center of the bob here is same thing as the length from B to A. When this bob was here, the length is from B to A, which I will take it as L, and from A to O I will take it as the radius of the earth. Now when it is slightly displaced, let this angle is equal to alpha and this angle is equal to beta, and if m is the mass of the bob of the pendulum, then due to the gravitational force between the center of the earth and the mass, its weight will be exactly to this side, towards the center of the earth, that is mg. Now let this point, I name it as OAB, let it be C. So if you look at the triangle OBCO, this is the exterior angle. And how much will be that? That will be the sum of the two interior angles. That is, this will be equal to alpha plus beta. So this angle, I write it here, will be alpha plus beta. Now, then which component of the force mg will be to this side? It will be mg times cos of the angle alpha plus beta. And this component, I am writing it here, it will be mg times sine of alpha plus beta. This is very simple. As you know, given a force like this, if this angle is theta, then this component becomes f cos theta and this component becomes f sin theta. How do you do so? If you take cosine of this angle theta in this triangle and cross multiply, you get this as f cos theta. And in this triangle, if you take a sine of this angle and cross multiply, you get this side, that is same thing as this side, as f of sine theta. Now, so this is your mg times cos of alpha plus beta, where alpha is this angle, beta is this angle. So this angle is the exterior angle of the triangle OBC. Now this component of mg will be mg times sine alpha plus beta. So to explain it better, I have redrawn the diagram on the other side. Come here. So come here. Now let me rename OABC. This point was O, this point was A, this point was B, and this point was C. This I had taken as alpha, and this I have taken as beta, beta, as you can see it here. And this component and this angle was equal to your alpha plus beta, and this was, and to this side towards the center of the earth was the weight of the bob mg, and this was equal to your mg times cos of alpha plus beta, and this is your mg times sine alpha plus beta. Now, in this position, the length of the string, that is from B to C, is pulled to this side by mg times cos alpha plus beta. So the tension is this way. Right. So T is equal to this. T balances this. Now, if T is more than this, then the bob will move to this side. If mg cos alpha plus beta is more than T, then the length of the string will be stretched to this side, means the length will increase. Since the length of the string is neither increasing or decreasing, neither the bob is moving to this side, so T balances mg times cos alpha plus beta. So the only unbalanced force is this one, mg times sine alpha plus beta. Now, if this alpha is small, means when the bob is not here, is here, let's say here or here, then this one, this component of mg, that is mg sine alpha plus beta, will be exactly towards A, in the direction of A. So I have taken from B to A as the length of the pendulum L, length of the string, from A to O as the radius of the earth. Now it has been displaced to the right, so this force is opposite to that. So I put so this is the unbalanced force. So I put it, I write it as minus mg sine alpha plus beta. Now for small angles, this force can be written as minus mg. For small angles, sine alpha plus beta can be taken as alpha plus beta. Right. Now the question is, while deriving the time period of an SHM, the restoring force we had derived, F is equal to minus m omega square y. Let this displacement is x. So for y, I write x minus m omega square x. So therefore, minus mg alpha plus beta, therefore minus mg times alpha plus beta is equal to minus m omega square x. Now cancels, minus cancels. So your omega square is equal to g times alpha plus beta over x. So if you take square root, we get omega as is equal to square root of g times alpha plus beta over x. Now, since omega, as you know, is equal to 2 pi over t, so that comes out to be g times alpha plus beta over x, square root of that. We are interested to find t. So from here, by cross multiplying, you get t is equal to 2 pi x over g times alpha plus beta, square root of that. Right. Now, how to change this alpha beta to some other parameters. So now you'll go back to your school mathematics, in a circle, if this point is O, this point is A, this point is B, then this theta angle is equal to theta, we know is given by the length of this arc, that is AB over OA, that is the radius. Now here, if I consider AC as an arc of when the displacement of the bob is small, that is from here to here is very small, I can consider this length as an arc of a circle whose radius is L. So I can replace alpha as x over L, and again here I can replace beta as x over r. If this bob is close to point A, means the displacement x is small, then beta can be written as x over r, using the same concept, theta is equal to L over r. So your beta can be written as x over r. So these two values I will now substitute here. So your t therefore becomes t is equal to 2 pi x over g times, for alpha I write x over L, for alpha I write x over L, for beta I write x over r. Now if I take x common, it gets cancels with this x, so I am left with 2 pi 1 over g times 1 over L plus 1 over r, right, and square root of that. So this is what I wanted to derive for you. So t is equal to this. So your t is equal to 2 pi 1 over g times 1 over L plus 1 over r and the square root of the whole. So t is equal to 2 pi 1 over, this is 1, this is not a L, this is 1, over g times 1 over L plus 1 over r, square root of that. Now then how to apply it? Now since it is clear, now let us apply it to different situations. If the length of the pendulum is infinite, that is from B to A or from B to C is infinite. If L is equal to infinitely long, if you put L here infinite, 1 over infinite is 0. So your t becomes 2 pi, this part becomes 0, 1 over L. So you get 1 over g over r, square root of that, r comes to the numerator, so your t becomes 2 pi r over g, square root of that, time period of an infinite pendulum. Now time period of an infinite pendulum. Now if L is small and r is very large, as you know, for radius of the earth is equal to 6400 kilometer, that is equal to this into 10 to the power 3 meter. Therefore 1 over r is very small. So the expression t is equal to 2 pi times 1 over g times 1 over L plus 1 over r, square root of that, can be reduced to, this is now neglected. Now L comes to the numerator, so your t becomes 2 pi L over g, square root of that. This is what you have derived in your school days or college days, but not in this manner. Now they might ask you, the length of the pendulum is equal to radius of the earth. Now if L is equal to radius of the earth, then what will be the time period? Now for L substitute r. So your this expression t now t becomes 2 pi a 1 over g times 1 over r plus 1 over r, because for L I substitute r, so this becomes t becomes 2 pi 1 over r plus 1 over r, 2 over r. So r comes to the numerator, so r over 2g square root of that, right? So they might ask you if the length of the pendulum is equal to L is equal to r over 2, then similarly you make a substitution here for L equal to r over 2 and do the necessary calculation. You will find out the time period of the pendulum. So this is a general formula for time period of a pendulum, that is t is equal to 2 pi 1 over g times 1 over L plus 1 over r, square root of that, where L is the length of the pendulum, r is the radius of the earth, right? So thank you very much, and you must have previously done numericals let me get a new paper. You must have previously done numericals like time period of a second pendulum, t is equal to 2 pi L over g, where t if 2 seconds, then it is called a second pendulum. By putting 2 here, you get L is equal to nearly 1 meter. And you must have done before time period of a pendulum moving in a left vertically upward with acceleration t is equal to 2 pi L over g plus a square root. That is, the denominator increases, therefore time period decreases. Similarly, you must have done time period of a pendulum inside a lift which is falling down with acceleration at t is equal to 2 pi L over g minus a square root of that. The denominator decreases, therefore time period increases, means the pendulum vibrates slowly. And also if the lift is falling freely, a becomes g, so g minus t 0, so something by 0 is infinite, so t becomes infinite. And you must have also done a case like this, a angle theta, this is sliding down. If a pendulum is hanging from here the time period had come out to be t is equal to 2 pi L over g cos theta, square root of that. So these are the different expressions, and thank you.